I'm going to get started on my report, in which I am going to model the number of physicians in small cities in the 1980s. I've already created my description. You can see it here. The number of physicians in a city can be a key variable when considering the opportunity for healthcare in that city. In this report, I will use data from small cities in the 1980s to explore the variables that are related to the number of physicians in a city. My intent is to find a parsimonious model that can account for the variation among physician numbers across small cities. Specifically, I will examine the relationship of the number of hospital beds, the per capita income, and population density as possible relating factors. And then I have the source of the data, which is the Rating Guide to Life in America's Small Cities, published in 1990. Now, the first thing I'm going to do, even above the description, is I am going to set about to read in my data. So I'm going to create a code chunk. And I always like to begin by making sure that my environment is completely cleared. And this funny command, remove list equals ls, that will actually remove all the objects in my environment. Now, my environment right now has stuff in it, so if I click on this, you'll see the environment's now empty. I always do that to make sure that whatever I see on my machine when I do my final run is the same thing others will see when they do the final run on their machine. To increase the compatibility among our machines when we run, I always like to use the here library. The here library allows me to indicate a folder and a name of a file in that folder, no matter where that folder is located on my machine. So I always put my data in a data folder, and anyone else who does the same thing will be able to use this same command, even though we might have different paths to that data. So I am going to save into a new data object, which I'm going to call health. I am going to save into that object using the read.csv to read in the data, and the here library, well, the here function, which is in the here library, I am going to go ahead and put that this is going to be in the data folder, and the name of the file is health data from small cities. And it is a CSV file because even though I originally obtained it as an Excel document, I've converted it to CSV. I don't want any of this to show up in my final report, and I don't want any messages or any kind of output. So I'm going to click on this little icon here, and I am going to say, show nothing, but run the code. And all that does is automatically put the include equals false up here at the top of my code chunk. Now, if I run this, if all is set up correctly, I should actually load in data, and I have. Notice that we have 53 observations of 4 variables. That is 53 cities. We don't know what they are, but there are 53 cities that have been selected at random from across the United States, and these are small cities using whatever definition the author did for small cities. And we have doctors, hosp.beds, which is hospital beds, income, and density. And as I've mentioned before, the doctors is physicians per 100,000 residents, the hospital beds is per 100,000 residents, and the per capita income is in thousands of dollars. So that when I look at income here of 9.1, that actually means per capita income of $9,100. I told you these were old data. That would not work very well today. Okay, so those are my data. They are already in. Now, at this point, it would be often the case when we would want to explore univariately each of the individual 4 variables that we're going to be looking at. And that would be a fine thing to do. However, I am not requiring it because we have so much to do and so much to learn that I am going to assume, if you have taken a first course in statistics, that you know how to do all that and could study those. If you were writing this up for a research journal, you would want to do some at least small preliminary analysis of each of those variables. But we're going to go ahead and skip over right into bivariate analysis of these variables. So my next section is going to be the analysis section. And in the analysis section, I am going to, first of all, want to look at a graphical display. So I'm going to go ahead and look at scatterplots. Let me go ahead. I obviously need to add some text down here at some point, but let me go ahead and create those scatterplots. Now, what we could do is make an individual scatterplot for all the possible pairs of variables. We have, in fact, in our data 4 variables, and as a consequence of that, we could make, let's see, it would be, well, it depends upon if we make each scatter plot one time or if we switch the variables in terms of the axis they are on to make them 2 times. But at a minimum, we would have 6 scatter plots. And I know that because the formula for that is the number of variables times number of variables minus 1. That would be 4 times 3, which would be 12, divided by 2 is 6. So there would be 6 scatter plots. Now I could make those 6 scatter plots all individually, or what I could do is use some R code in order to create all the scatter plots at once. There is actually a function for that. It's called pairs. So let me go ahead and put that in there. I'm going to go ahead and copy in the code. And there it is. So what does this do? What this does, this pairs command, with the little tilde to start it, is it asks us to take all 4 of these variables. Notice that we're not actually adding them together. That's just the argument code that we need. It's taking those 4 variables together, and from those 4 variables, it is going to then create the scatter plots of the variable pairs. So I'm going to go ahead and run this so you can see what I mean. And there it is. A little bit more difficult to read than if we had created all the individual scatter plots. You might also look at this and count and say, wait a minute, you have 12, not 6. That's because we have physicians on the vertical axis in this first row and physicians on the horizontal axis in this row. Now, physicians is the response variable, so we really only need it on the vertical axis right here. But notice we're also looking at the explanatory variables and looking at the relationships of the explanatory variables with each other. And we can't put both of those variables on the x-axis. So there it's a matter of, well, does it make sense to have one of them on the x and one on the y? Does it make sense to have income on the x and hospital beds on the y? Probably. Does it make sense to have income on the y, like this one right here, and hospital beds on the x-axis? Probably not. Probably there are more hospital beds when there's higher income and the income is causing or driving that as opposed to the other way around. But it could be argued multiple ways. So this is a simple little way to get a plot so we can see some basic initial relationships. What am I seeing when I look at this? I'm seeing a little bit of relationship here, except then you have all these points up here that are kind of outliers that are perhaps influencing that relationship. I see if I look at density related to physicians, looks like almost a horizontal line, which would indicate no relationship, not much going on there. So again, this is just really a rough overview. If I wanted to get more precision, I could make each of these individual scatter plots, but I would not expect anyone to do that, especially if you got more than 4 variables. I will also mention that there are some packages in R that do a much better job of this so that you can actually get these multifaceted plots in which they're much more readable than this particular one is. But for the moment, we will stick with this. Okay, I'm going to go ahead and keep that scatter plot in there. However, I want to put a figure heading in here, and so I'm going to get rid of this main argument here because that main argument put in that main heading, and I'd rather have just the scatter plot and then put in a caption myself. Also, I want to hide this code from my report. So I'm going to go over here to output and say that I want to show the output, but I don't want to show the code. So when I apply, that will put an echo equals false. The difference is up here include equals false is it will not even show output. And there was none to show up there except perhaps messages that I don't want to show up in my report. Down here, I do want to show this scatter plot. So I'm going to go ahead and put some text with this. And see what you think of this text. The scatter plots in figure 1 illustrate the zero order correlations among all 4 variables. Now, what about that term zero order correlation? A zero order correlation is a term that means we are looking at just a bivariate relationship. As we will see later on in another unit, there are other kinds of correlations we can create which we look at more than 2 variables at a time. But zero order is another way to say we're looking at bivariate relationships. We're looking at them at pairs at a time, individually, without the other variables involved. I'm looking at those among all 4 variables, 1 response variable and 3 potential explanatory variables. There appears to be some weak relationships, but nothing really strong that I see. This doesn't look too bad when I'm looking at physicians and income, but it doesn't look terribly strong either, or those points would be more clustered around a line going up from bottom to top. That does give us an indication that as income grows in the cities, the number of physicians grow as well. That should not surprise you. It doesn't surprise me. One other thing that I need. I have mentioned figure 1, but I have not labeled this figure 1. So I'm going to create a caption here to create this as figure 1. So there's my little caption indicating figure 1, and I'm going to put that caption in italics that this is a scatterplot matrix of 4 variables from small cities in America. So let's see what it looks like so far. We don't have a lot going on here yet, but let's go ahead and see what it looks like. We could hit the preview if we want, but I always like to knit. So I'm going to pull down this little arrow. I'm going to knit to HTML, and it creates for me a little a little display of what this is going to look like. Everything looks good. The one thing I don't really like is that that figure 1 is as close to this paragraph above as it is to the figure itself. And the way I typically handle that is to put additional space after this paragraph. There are multiple ways to do that, but one way not to do it is to just add space, like you were in a word processor. That doesn't work. Let me go ahead and save this and knit it, and nothing has changed. There are actually multiple ways, multiple symbols we could use to add space. The simplest one, I find, is to use this downward slope slash, that is from left to right going downward. So I'm going to put in 2 of those, and I don't believe I need to even leave space there between them. If I put in 2 of those, let's see what happens. And did that make space? Maybe a little bit of space. Let me put in another one. Okay, that looks good. So here I refer to figure 1, and now it's very clear that this caption goes with this figure rather than up here. Again, if you were using additional R packages that are designed to make nicer looking faceted scatter plots, they also are going to have a nicer way to put in a caption. So that's something to explore on your own or in the future. But for what I'm doing right now, I'm just working in base R, and we're focusing on the underlying statistics and the statistical knowledge and some basics in R in order for us to analyze the possible models that we're going to analyze. One more thing I'm going to do real quick, and that is go ahead and put in the correlations with this. Let me go ahead and put in some code for that. And that code is simply, then I can put the text around it. It's just this. You use the core command for correlation just the way you would for 2 variables, but if you put in the data frame, then all the variables will actually appear in a correlation matrix. Now, one word of caution. If your data frame doesn't have all quantitative variables in it, this could end up being a problem, and we would have to figure out a way, and there are nice ways to select which columns we want to include in the matrix. Or if you have, for instance, variables that you're not wanting to include in the matrix, there are nice ways of doing that. But in my case, remember with these data, I want to include all 4 of those in the matrix. I did that in the scatter plot, and I want to do it again now here for the correlation matrix. So when I click on this, I get that nice little correlation matrix, and I will label this as a table and put some text in for this. So let me go ahead and do that. Okay, so the first thing I'm mentioning here, and this could be done in the description, but I decided to do it down when we started looking at the graphs and the correlations, is to indicate that the variables we see in figure 1 and throughout the report, how they're defined. Again, we could have taken this without the term figure 1 and put it up in the description, and that would have been fine. It's really a matter of your personal preference on how you did it. I decided to do it while people were looking at the variables at the analysis. So now I reference table 1 as a correlation matrix. I'm going to go ahead and do this. Remember, I need to shut off this code chunk here. So I'm going to show output only. And let's see how things look if we do this. Let's see what I say here. Table 1 is a correlation matrix among these same variables, Annual income per capita is moderately related to the number of physicians. Here it is, 0.43. That's a nice moderate relationship. Not real strong, not real weak. By contrast, look at density. Density related to physicians. It's hardly related at all to the number of physicians. And it has a pretty weak relationship with any of the other variables as you look down this column here. The largest one is with hospital beds, it's 0.19. Remember, this is population density per square mile, but the population is also taken into account in the hospital beds because it's per 100,000 residents, which is why it's not surprising there's not a strong relationship there. I say for this reason, I decided to discard it from further consideration in developing a model to predict the number of physicians in a small city. But you know what? I am going to consider it in a possible model. And I will explain the reason why. I'm not simply going to look at that zero order correlation and say, oh, this isn't going to work. Now, we might find out that it really doesn't help much in our models. I'm kind of predicting that's going to be the case. But let's go ahead and look at it anyway, and let me talk about why we have to be careful about discarding variables just because they have low correlations with our response variables. All right, so I've kind of got a descriptive setup all going here. Let's go ahead and end this video, and I'll continue this report and some instruction on statistics in the next video.